Morning, guys. Right, we will start with the homework from Monday. Just let me find it here now. Okay. So, we were talking about linear patterns, and I asked you to do 3 questions. So the first one here, we wanted to identify the start term in the sequence. So the start term is exactly what it says. It's the first term, the starting term. So in this question, the starting term is 5. Part 2 is find the common difference. So the common difference is how much it's going up or down by. So in this case, is that plus 6? Yep, so I think the common difference is 6. Fill in the red boxes. I've done that. They're the first difference or the common difference for each sequence. Hence, find the next 3 terms. Okay. So we're going to get 17 and we're going to add on 6. I'll do this in black. That brings us to 23. Add on another 6. Brings us to 29. And then add on another 6. Brings us to 35. So the next 3 terms are 23, 29, 35. Oh. Okay, and write a sentence to describe each sequence. Okay, so obviously we only did the first one. So sequence A is a linear sequence with a start term of 5 and a common difference of plus 6. So they were the 3 key pieces of information I asked for. What type of sequence, what's the start term, and what's the common difference. They are your 3 pieces that needed to be mentioned. Okay, alrighty, that's the first one. The second one, down here, 3A. Write down the missing terms of the following sequences. Okay, so what's going on in the first one? 1 to 5, that's plus 4. Zoom in a little bit. 5 to 9 is also plus 4. Okay, so if we plus another 4, we get 13. Plus another 4 is 17. Plus another 4 is 21. And plus another 4 is 25. 29 and 33. So you were missing 13 and 25 there. Okay, question 4. Use the following rules to find the first 4 terms of each linear sequence. Okay, so they want us to start at 0 and add 2 every term. So start at 0, so there's my start. Add 2 will bring me to 2, another 2 will bring me to 4, another 2 will bring me to 6. And that is 1, 2, 3, 4. And they wanted 4. So 0, 2, 4, 6. And the last one. Describe in your own words each of the following linear sequences. Okay, so again, we need to get these 3 key pieces of information in. So 5A is A. Okay, so is it linear? This is 5. 8 to 13 is 5. Yeah, 5. Yeah, it is. Okay, so is a linear sequence with a start term of 3 and a common difference of +5. Okay. So that's the homework. Hopefully that went okay. So we'll pop back in here and we'll have a look at some non-linear sequences. Okay, so these are sequences. These are sequences that when you draw the graph, you will not get a straight line. Okay, non-linear, not line, not a straight line. Okay, so a couple of actually in some of the classes were asking about a sequence that looked a bit like this one. So sequences that go up and down. So there's a pattern to it, but remember that for a linear sequence, you must have a common first difference. If you don't have a common difference, you don't have a linear sequence. So I think one of the examples that was given was like this: 7, 14, 7, 14, 7, 14. So, I mean, is it a pattern? Yes. How do I define a pattern? I define a pattern because the next term is predictable. Do I know what the next term is? Yeah, it's definitely going to be a 7, followed by a 14, followed by a 7. But is it a linear pattern? Okay, and if we look at the common difference, that is +7, that is -7, that is +7, that is -7, that is +7. So these numbers are not the same. So that means that example would be non-linear. Okay? Now, there are some non-linear patterns that are special patterns themselves. Okay? I might just go off to the side actually to explain this. So an important non-linear pattern. Okay, so let's look at this sequence. They had it there a minute ago. Okay, so let's investigate if this sequence is linear. So from 18 to 20 is +2. From 20 to 20 is plus nothing. And from 20 to 18 is actually -2. So if I look at those numbers, okay, so this is definitely not a linear pattern, right? Because we do not have a common, now we talked about this a little in the homework, a common first difference. I'll explain why the first bit is important, okay? Watch what happens when we look at the difference of the difference, okay? So to go from 2 to 0, from 2 to 0, that's down 2, yeah? And from 0 to -2 is also down 2. Okay, so what you have here is a common, sorry, I'm going to write the words. You have a common second difference. Okay, can you see what I mean by first and second difference now? So when you do the difference thing the first time, that's called the first difference. And if that's common, it's linear. And when you do it the second time, which I'm after doing here, if you get a common number on the second difference, then this is a very important non-linear pattern called a quadratic pattern. So if you find a common second difference, we have a non-linear pattern, and specific because there's loads of non-linear patterns. But if you have a common second difference, it's a specific non-linear pattern called a quadratic pattern. Okay, that is incredibly important, and you need to write that down. Okay. Oh, sorry, don't know what happened there. Where were we? Okay, so here's another 4, 8, 16. Oh, okay. I don't think I want to do that one yet. Okay, so there's another 2 patterns I want to talk about, but we're just going to stick with quadratic for today. So we now know 2 patterns, right? We know the linear pattern, which has a common first difference, and now we know the quadratic pattern, which has a common second difference. Yeah? Okay, so that's what we know so far. I am going to teach you 2 more. So that's the first one, the second one, there will be a third one and a fourth one, just not today. Okay? So let's hope the third and the fourth don't pop up in this example. So for each sequence, identify the type of sequence, so whether it's linear or non-linear, and give a reason for your answer. Okay, so we won't do them all, but we'll do the first one anyway. So 5, 11, 17, and 23. Okay, so let's investigate if it's linear. So to check if it's linear, we need to look at the first difference. So going from 5 to 11, that's plus 6. Going from 11 to 17 is plus 6. And going from 17 to 23 is plus 6. This one does have a common first difference, which means it is linear. Yeah? Let's look at the second one. So 2, 6, 18, 54. Okay, so let's look at the first difference. 2 to 6 is plus 4. 6 to 18 is plus 12. 18 to 54 is 36. Okay, so it is definitely, we do not have a common first difference. So it is definitely not linear. Okay, so we'll go on and look at the second difference and see if there's a pattern there. So 4 to 12 is plus 8. 12 to 36 is 24. So it does not have a common second difference. So it is not quadratic. Okay? So for that one, the best we can do is say that it is, I'll do it in black. Sorry. It is a non-linear pattern. Okay? It's not a quadratic pattern, but it's definitely not linear. So it's some other type of non-linear pattern. Okay, so that's the best we can do for that one. The third one, we may as well finish it, is 2, 15, 36, 65. 2, 15, 36, 65. Did I get that right? 2, 15, 36, 65, right? So we will look at the first difference. That is plus 13. This is plus 21. And this one is plus 29. So we have no common first difference. So it's definitely not linear. Look at the second difference. That's 13 to 21 is plus 8. And 21 to 29 is plus 8. Awesome. So we have a common second difference, which means this sequence is quadratic. So this sequence is a non-linear quadratic pattern or sequence. All right. So the first one was linear. So that's a linear sequence. That's fine. The second one, we checked for linear. It wasn't linear. We checked for quadratic. It wasn't quadratic. So we can determine that it's definitely not linear, but we can't really tell any more about it than that. So I've just said it's not linear. The third one, we checked was it linear? It wasn't. We checked if it was quadratic, and it was. So this is a non-linear, and we can be a bit more specific for question C because it's quadratic. Okay? So oh my God, why does it keep doing that? I would like you to do okay. So we'll do question 8. I'm just going to pick randomly. So we'll go A, B, and E. I don't know what's going to be what. And then I want you to do that one there, question 9. Can I get up? No, I can't. Okay, I'll snip these over. So this is linear and where's the homework? Here. So Wednesday, the 10th, linear and quadratic sequences. There's the first part, and go back in and, oh my gosh, it's not annoying at all. Okay, get the second part. And just make that back. Right, so that's it. That's your homework, and that is due for Friday. Okay, let me know if you have any issues.